A very important parameter, charger is slow or fast. What is slow, what is fast? A slow basically means it will charge the vehicle slowly, fast means it will charge the vehicle fast, very simple. But what is slow, what is fast? This is not often understood, and the marketing people all confuse this. They are experts in confusing this. Let us understand what has to be charged. Range of vehicle depends on the usable capacity of the battery. Usable capacity. Usable capacity is battery capacity multiplied by state of health multiplied by depth of discharge. Depth of discharge means you are not going to use the full capacity. State of health, whether the battery is deteriorated. So, you may start with a 10 kilowatt hour, but multiplied by state of health and DOD, and it goes lower. Batteries behave when they are slow charged. Now, this is the definition of slow charge, 3 hours to 10 hours to full capacity, and they behave best if you charge at 25 degrees centigrade. Most batteries actually, this is the best thing to do. Ideally, if you want the best behavior, you charge in 7, 8, 10 hours. If you cannot afford 7, 8, 10 hours, you can do 5 hours, 4 hours, maybe 3 hours, but that is a more or less limit. 3 hours starts hurting the battery, slow charge, but this is slow charger. What is a fast charger? A fast charger is one, and why do you need fast charger? Because I want to go, I have come, I have got stalled, so I want to charge fast and run. Charge in an hour or less, 30 minutes, 15 minutes, the chargers available for all this. These are fast chargers. They are at 1 hour basically means 1 C. 10 hours basically meant 0.1 C. 1 hour basically means 1 C. 15 minutes means 4 C. So, 20 minutes means 3 C. So, typically they are charged 1 C to 3 C charging. This is a fast charger. You may go 4 C, but that is extreme case. Of course, if the vehicle have to go longer distance, either they require fast charging or use battery swapping. We will discuss this later, battery swapping. We have already discussed this, but let us discuss the slow charge and fast charger. A very big confusion is created by saying a charger is a fast charger or a slow charger. That is not correct. Charger in itself does not make it a fast or a slow. A charger vehicle combination will make it slow or fast. Why? We have just told you 0.1 C to 0.3 C is a slow charger, whereas 1 C, 1.5 C, 2 C, 3 C, 4 C is a fast charger. Charging, fast charging, not charger. Now, this takes 20 minutes to 1 hour. Let us take a 5 kilowatt hour battery and it is charged at 1 kilowatt or 2 kilowatt. It is a slow charger, obviously. Thus, the charger power output and battery size together determines the slow charger. But let us take 1 kilowatt hour battery. So, I have a charger which is 1 or 2 kilowatt. If it is a 5 kilowatt hour battery, it is a slow charge. It is a 1 kilowatt hour battery, it is a fast charge. Remember that. I am charging 1 C. So, same charger can be fast charger or slow charger. Fast charger for some vehicle, 5 kilowatt hour battery if I have a large 3-wheeler. I may have 5 kilowatt hour battery and I will use this charge, I will charge in 5 hours, slow charging. But if I can charge at 1 kilowatt hour and my battery can take it, and I have a small 2-wheeler with 1 kilowatt hour battery, I am charging at 1 C rate, it is a fast charge. My battery may get damaged, that is a different issue. But suppose my battery has the capacity, it can become fast charge. So, in itself a charger is not slow charger or fast charger. Charger power output plus battery size together determines if charging is fast charger or not fast charger. Should give some assignment problems on this, it is an important point. So, need to look at traction. Now, what is the size of the battery? Need to look at the traction power. 2 kilowatt hour, 2-wheeler battery, you will need 1 kilowatt hour to 3 kilowatt hour. E-rickshaw battery, 2.5 kilowatt hour to 5 kilowatt hour. E-auto battery, 3 kilowatt to 6 hour, plus 6, 7, 8, 9, 10. Small car battery, 15 to 30 kilowatt hour, large 30 to 75, bus battery, 100 kilowatt hour to 400 kilowatt hour. So, size of the battery will depend on how much energy you will use. Thus, a 10 kilowatt charger is fast for 2-wheelers and 3-wheelers, but 2-wheelers or 3-wheelers are slow, and slow for 4-wheeler and buses. A 10 to 20 kilowatt is fast for 2-wheeler, 3-wheeler and small 4-wheelers. Small 4-wheeler may be 20 kilowatt, it may have a 20 kilowatt is fast for 2-wheeler, 3-wheeler and small 4-wheeler. Small 4-wheeler may have a 15 kilowatt hour battery, 20 kilowatt is fast charger, but slow for large 4-wheelers and buses. A 50 kilowatt hour or 100 kilowatt hour charger is fast for most vehicles except for trucks and buses. So, this is a common fallacy not understood. Battery size and currents at sea, this is an important parameter, very often not understood. A typical cell voltage, NMC cell voltage is 3.7 volts and a certain current rating, could be a 15 ampere hour, could be a 50 ampere hour, could be a 3 ampere hour. 1C basically means X ampere of current will flow through the cell. If there is an internal resistance, all cells have internal resistance, and a battery may have more. The heat dissipation at 1C will be the current X amperes square I square multiplied by the internal resistance. Each cell of battery dissipates this amount of heat. If the total number of cells in the battery is Y, the heat dissipated is X square into Y into IR. So, at 1C, the total power of the pack is at 1C, total power of the pack is 3.7 volt into 1 into X into YY. Well, X is the current rating and Y is the number of cells. So, this is the power. So, what is the heat generated, total heat generated in terms of percentage? X square Y into IR into 100 divided by the total power generated 3.7 into X into Y, or which is X into IR into 100% by 3.7 of the total discharge power at 1C. So, at 1C, depending on the total amount of power you are charging or discharging, what is the percentage of heat that is generated, that will result into losses. This is a battery loss, this is not even a charger loss, and that much heat will be generated. That heat will hurt the battery. Let us take 3 different sides of cells, prismatic cells, cylindrical cells and pouch cells. You have learned about them. Typical internal resistance of a prismatic cell is 6 milliohms. For a higher AH battery, higher may be even 1.5 milliohm. For example, 50 AH battery, it is 1.5 milliohm. Cylindrical, it is typically 25 to 35 milliohms, and pouch cell 1 to 2.5 milliohm. It can even be less for even higher AH. So, this is what it is. So, typical battery at 1 C rate, what is the total power, percentage power dissipation. If I am using a 4H AH cylindrical cells, small cylindrical cells, my power dissipation is 3.8% of the total charge that I am charging, 3.8%. For 15Ah it is 2.5% and for 50Ah pouch cell it is 2%. Now, this is important. I am dissipating more heat at 1 C. Now, this is at 1 C, and if I use 2 C, the heat dissipation will go up by 4 times. Okay? Now, that significantly will heat the battery. At 2 C charge, it will be 7.6%, 5% and 4%. You must take all this into account. Where will this heat go? You are charging at, let us say, 2 kilowatt, and if you are dissipating 7% heat, means 150 watts of heat is getting dissipated all the time. Temperature will go up like anything. Your battery will get spoiled, you will require cooling. So, these are the important things that is often ignored. The next question that I will ask, are batteries capable of being fast charged? Answer is yes and no. Not all batteries can be charged fast, but fast charge has any fast charge has an impact of the battery. One has to ensure the batteries are ready for fast charge. It is using cells which are capable of doing 2 C, 3 C. But after cells, you have to understand whether pack is ready. Cells will, so if you fast charge at 1 C, 2 C, cells can get spoiled fast. But even if the cells are capable of not getting spoiled, that much heat is generated. So, you have to now worry about, well, the pack capable of getting charged fast. Without cooling, they are not. Depending upon the type, some batteries may be charged at 1 C once in a while some others may charge very occasionally at 2 C. Still something others are 3 C or 4 C without significant degradation of life. These are batteries capable of fast charging, and they are going to be expensive. Discharge rate normally is always can be higher than charge rate. Now, discharge rate will also dissipate heat, but generally discharge rate does not hurt the cells as much. So, typically a cell will be said do not charge above 0.5 C, but discharge rate you could go up to 1.5 C and occasionally even 2 C. So, all cells by very design will generally allow higher dissipation, but charging slowly, which basically means when you charge at a station, you charge slowly. Then in a vehicle, if it has to occasionally use higher power, it is okay. So, this is a good thing. Temperature management will always be an issue. So, how long does the fast charging takes? 1 C charging will take 85% DOD in 51 minutes. But look at the typical charging curves. Take 1 C charging. So, it will reach 80% in 51 minutes. After that, it will be flat. This is the voltage will be constant, and this time may be very long. It will not get filled, what I am pointing out. It does not charge to the full if you charge at 1 C rate. So, constant CC charging, constant current charging ends constant voltage starts taking much longer time. For example, 2.5C, you will say, oh, I will charge in 20 minutes, but you will only be able to charge up to 57%. This is for a typical battery, battery will change, you can go higher. After that, it takes much longer time to charge the remaining, because you are charging at very low current. Now, charging characteristics that I have given is chemistry dependent. So, you need to get this charging characteristic for a cell. For example, 4C charging is possible with higher cost LTO battery, 15 minutes, and you will be able to get to 95% charging. Partial charge for vehicles with large battery, that is possible. For example, if you have a battery with a vehicle with a 600 kilometer range and you are only charging for 200 kilometers, that you can charge in 15 minutes. That will well fall within this rate. It will not reach there, you are not fully charging. Why? Because you are driving and suddenly your home is still 125 kilometers away and your battery is running down. Now you can charge for 15 minutes, fast charge. So, that is possible, because even 200 kilometers will get me there, and after that I will charge overnight. So, partial charging of small battery does not give you much, because the range is only about, let us say 50 kilometer for a 2-wheeler. Now, if you partial charge, you only get 10 kilometers extra. Well, that may be enough sometime, but mostly no. Okay. So, the partial charge concept is for large battery, large vehicle. The next very important question is the grid ready for EV chargers? Is there sufficient power on the grid? If I start putting chargers, will the grid get overloaded? Remember, power generation is no longer an issue, but is the grid having sufficient capacity? Grid can carry only finite amount of power. All the wires are laid to for certain amount of power. What if I start drawing more power? For slow chargers, small slow chargers, 300 watt to 3 kilowatt, it is not an issue. It is like an air conditioner. Air conditioner typically take 1.5 kilowatt. I like 2 air conditioners. We do not have to ask every time the electricity supplier, can I put an air conditioner? I just put an air conditioner. Similarly, a slow charger I can put, I do not need to ask. But if I want a fast, higher power, higher than 3 kilowatt, then I may draw a lot of power. Then one has to correspond with electricity department, say I want a 20 kilowatt charging or 50 kilowatt charging, give me the connection, they will demand the certain amount of cost for laying new wires, and then it is like wiring a new house. So, of course, as I pointed out that peak power requirement may be difficult to meet as more and more fast chargers come in, and therefore, you may use what is called time of use or time of TOU or TO time of day metering, so that also grid may limit the output power. It may, even if the charger is capable of doing it, it may not allow you to charge. You require a communication saying now do not take more than 10 kilowatt. So, this is what is possible. Is there a possibility that I have lots of charged batteries and my grid is short of power? Can I supply power back from EV to the grid? Yes, it is possible. This is called EV to grid. We will not discuss this too much in this introductory course, but EV to grid, particularly in Europe, is becoming very common now, because there are large number of vehicles. When there are small number of vehicles, it is of not much of importance. So, this is the end of chapter 7.1 and 7.2, and I have given an assignment. The next section is on swapping. I did a introduction to swapping in the introductory chapter. This is getting into swapping in more details. The basic reason is the primary cost of electric vehicle is in this container, the container of electricity battery. Can I avoid buying a battery? Petrol pump costs, petrol tank costs very low. So, I put it along with the vehicle. Can I, instead of filling the petrol in a petrol tank or filling the electricity in a battery, can I take battery, swap it? Of course, it will be size could be big, could be a little heavy, but remember that we are used to LPG gas cylinders swapping. Whenever it runs out, we bring a new LPG gas cylinder. Can we do the same thing for battery? Why? Because battery cost is very high, and that is called battery swapping. So, we had learnt in section 4.7 that to convert how to convert battery capital cost into operational cost, not just taking the capital cost and life cycle, but also discussed the dependence of life cycles on the rate of charging, discharging, temperature, depth of discharge and interest rate. So, now we propose a mechanism for EV users to not purchase, but lease charged battery, and once it is discharged, give it away and swap another charged battery, and simultaneously solve the vexing problem of range anxiety. Range anxiety, why is the range anxiety there? Range anxiety is not there in petrol vehicles. Why? There are petrol pumps all over. You drive into a petrol pumps, you can fill in 2 minutes and drive on. So, you are never worried. Can we do the same thing? Can there be as many swapping station where battery that I need is available? I go, my battery is getting discharged, take it out, get the new battery, drive on. Battery will not belong to me, battery belongs to the operator. So, suppose, and of course, I have to sign up with one particular kind of petrol pump. So, suppose I sign up with BPCL. So, BPCL is a petrol pump, petrol station, it is called BPCL. So, I will go to any BPCL petrol pump, they will have charged battery of my kind, I will give that battery, take their battery, and I will give it back to another BPCL petrol pump. So, it always will be BPCL property. Okay? That is basically, so I do not have a range anxiety, I can do that in 2-3 minutes. So, the customer may purchase the vehicle without battery, very low cost. When battery runs out, customer leases the battery from an energy operator could be BPCL. When battery runs out, customer goes back to the same energy operator and any of his or her outlet, any of the operator's outlet, and swaps discharged battery and give back, and I pay the usage fee. Could even depend on how much battery that I used. Somewhat similar to LPG gas cylinder, except LPG gas cylinder we give it only when it is empty. Here we may not, it may even empty it may be partially charged. They can measure the amount of energy that is there, and we will pay only for the usable part. Recognize that battery is a mere container of electricity. It is electricity that is used, that is important, not the container. Purchase of electricity as energy is now similar to purchasing petrol, except that customer pays for the usage of battery, for the energy plus the usage of battery. Now, since battery is very expensive, each time I use, we have calculated what is the cost per kilowatt hour, that also has to be paid back, plus some profit has to be paid back. So, it is the energy operator who purchases and owns batteries, sets up charging stations and multiple swapping station. Takes usage charges from the customer for charged battery during swaps. This is the concept of battery swapping. Time to swap a discharged battery could be a few minutes, no waiting time, no range anxiety, and you could do it very well. Energy operator swaps batteries at multiple outlets for user convenience, just like multiple petrol pumps. EV customer signs up with the energy operator, let us say BPCL, and can swap at any of his or her outlet. Charging at swapping outlet itself or some centralized charging outlet. So, there can be two possibilities. At every swapping station there could be charging, or the operator may take it to some centralized place, charge and bring it back, it is up to them. Energy operator ensures that charged batteries are always available whenever I need, if necessary by moving batteries from one location to another. Okay? All right. What will be the battery leasing charges? It will be based on the kilowatt hour used and how long did I keep the battery.